Hi, I'm Bryan Schrader, and you're listening to Outstanding in Your Field, powered by Pioneer Agronomy. I'm here with my co-hosts, agronomist Carl Joern and Crystal Williams.
Think of us as IT for your crops. If we know how to fix your issues, we'll tell you. And if not, we've probably got a workaround.
And if we don't, we'll find one because Mother Nature isn't like an on-off switch.
Welcome back to another edition of the Outstanding in Your Field podcast powered by Pioneer Agronomy. I'm pleased to be joined as always by my colleague and co-host, Bryan Schrader of Northeast Indiana. Bryan, how are you today?
Very good. Trying to stay cool today, Carl.
We got a hot forecast ahead of us, mid 90s, a lot of humidity. It's the middle of July and it's starting to feel and act like it. What's the status of the crops your way, Bryan? Quick update in that department.
I all over the place still. We've got some of the early April soybeans and the early April corn that was planted being actively sprayed for disease. Fungicide applications going on right now. A lot of those beans that were planted that first week of April were well into R3. Corn's been pollinating that early April for the last 4 or 5 days. So that's where we're at. The heat from 2 weeks ago, latter part of June, has been turned out to be very beneficial for our crop. It helped even some things up and really did not take the toll that I expected it to. I actually think it was a good thing for us. And so we've been fortunate to get a few rains here and there in some spots, few heavy spots. But overall, I think the crop's making pretty good progress is how I would say it.
Glad to hear it. Similar sentiments over this way. We were east recently, not in corn country per se. Last week we were in Pittsburgh, Pennsylvania for some agronomist meetings for Eastern United States and Eastern Canada as well. Great time, good meeting, a lot of forward-looking topics. And in that meeting, folks, we had a chance to visit with our resident corn breeder, Dr. Lance Merrick. Lance, welcome back aboard the Outstanding in Your Field podcast. Glad to have you with us today. Lance, I'm going to give folks a little bit of your background and you fill in the gaps before I get it wrong. But Lance has been with us. He's our corn breeder for the Windfall Research Station, serving the state of Indiana and also doing some breeding for the good listeners in Illinois as well. So really has a great background as it relates to Eastern Corn Belt genetics, the priorities that we talk about being important from the Pioneer brand standpoint. But please give us feedback from yourselves in the field if there's direction you feel we ought to be taking things that we aren't today. We're entering corn pollination, so folks are starting to think about disease development, stay green, all that stuff. High priority for Lance as he advances the bar for yield as well. But Lance comes to us from South Dakota State University for his training. He is originally from the state of South Dakota, has close ties to the Pioneer brand as he's got a rep brother that's a seller over that way. So what he does day to day, he gets to see the fruits of those labors for those folks that are listening to this. Not just a corn breeder by job, but it's a vocation for Lance. He did his PhD out west as you get over to Washington State, where he focused on some wheat breeding to kind of, build out those breeding chops. And today, we're blessed to be graced by his presence. So, Lance, you are no stranger to podcasting as a regular host of the Breeding Bites podcast, if I'm getting that right, that you do for the National Association for Plant Breeders. So, with all of that preamble, Lance, thank you for joining us on the Outstanding in Your Field podcast.
Thank you, Jason. Thanks for the invitation. That was a great introduction.
This is what happens when you get to have a beer with a breeder. If I'm hearkening back to a previous Pioneer campaign, Lance shared with us he was willing to come back on, and it did not take very much twisting of the arms of Bryan and myself. We'd love to get Lance's perspective. So Lance, I've been an agronomist for long enough now, not as long as Bryan, but long enough that I feel as though I know the agronomy side of the things pretty well. But breeding is a total black box. How do we get a corn hybrid into a Pioneer bag? Where does it start? Maybe lay this out for folks as they're listening to maybe their first visit with a corn breeder in some time.
Yeah, great question. It's a long journey, right? It takes, anywhere from 7 to 10 years to develop that corn hybrid, right? I like to call corn breeding 2 breeding programs in trench coat because, we what you see out in the fields, those are hybrids, right? We cross two inbreds, and those are the ones that, the vast majority of our breeding program is actually based off of developing inbreds. And those inbreds, we can make multiple, combinations in the field, utilizing, a lot of different technologies and methodologies to do that. Um, but it's kind of a, two-part process, right? So what you see out in the field is more on the back end of a lot of my breeding program and a lot of my breeding effort. I spend a lot of time in the hybrid field still, but most, outside of the summer, a lot of my time is really spent on, the computer and things like that, because, when you talk about that black box, the easiest way to peer inside of it is through predictions and things like that, right? New technology, new computer simulations are to help us really dive deep into our germplasm, right? And make better and better selections. And you can see that, in the increase in performance and strength throughout our pipeline and throughout our portfolio, right? Traditionally in plant breeding, it was a lot of pedigree selection, and it still is quite a bit, right? It comes from breeder knowledge to really understanding that pipeline and understanding that germplasm. But now, in the era of predictive modeling and things like that, we have tools that we can utilize to allow us to kind of peek behind the curtain, right? And kind of simulate out our entirety of our pipeline. And because of that, we can actually make a very robust pipeline through predictions and, never entertain some of those poor germplasm that actually makes it through, you know. And so we've just seen, large increases in performance just solely based off of being able to actually make selections early in our pipeline. So when we actually start looking at them in the field and then making hybrids with them, we have only the best of the best can make it through, right?
Lance, I'm thinking about, you got, I'm going to use a metaphor here, and maybe we'll see if I get this or not. Say that you're in charge of a major league ball club organization, right? And you've got this farm system of countless prospects, right? You could call up anybody at any time. There's a process to get them, out of low A ball into double A, triple A, and eventually get their call up for a cup of coffee. They made it to the big leagues. You're going through the draft process. There are thousands, tens of thousands of eligible athletes that you could bring into your organization. Similar with corn breeding, right? You got umpteen combinations of inbreds one could use to make a hybrid that then gets advanced through the farm system, if you will, if we're going to continue using that metaphor for minor and major league baseball. If I'm hearing you correctly, we've got better scouts today that are able to go out and see those high school or collegiate ball players and say, yeah, based on his pedigree, we can simulate out how he would perform as a major league ball player. Not going to make the cut. Doesn't have the traits, doesn't have the tools. We never even have to get him in the organization. We can just say from the very beginning, this one's not going to make the cut. And then all those that you do draft, you've got a higher likelihood of hitting on a 5-tool player, a really good prospect that's going to make its way through the organization. Is that roughly how we might translate it into America's game?
Yeah, absolutely. That's a really great analogy. We like to think of breeding as a funnel. If you've ever been to pretty much any, breeding orientated, presentation meeting, I'm sure even you guys have probably had some breeding funnels on slides before that in prison, right?
Sure.
Traditionally, the beginning of that breeding pipeline, those inbreds are not necessarily even in hybrids, right? And so we never even see them in the field because we only do yield testing in a hybrid space. That means that the majority of our breeding pipeline is just kind of screening inbreds by visually looking at them and do purely based off of the background genetics and how well their parents did, right? And there's other methodologies like test crosses and things like that to get really down deep into it. But now we can actually simulate out the exact same trait profiles that we have in hybrids, right? Everything from disease resistance, sustainability, agronomics, things like that. We can predict into the entirety of our breeding pipeline. So in that breeding funnel, where we would have we go from a ton of lines with zero phenotyping, which means no yield presence, no yield testing, to, further and further down the pipeline, you have a handful of hybrids that you have in the field at hundreds of locations throughout the country. Right? So it's kind of it's a translational pipeline going from very little resources to a lot of resources, going from a lot of lines to only a small subset of lines, right? And because of that, there's you really only had a small number of resources to really look at that material, just because of creating populations, screening inbreds in your nurseries like we have here at our Windfall Research Center, things like that, right? Now I can do a majority of the beginning of the pipeline just solely on a computer, looking at those traits, doing predictions, right? And so really that number becomes infinite because I can screen any of my lines. And so just thinking about the pool of people that you have scouts in, now it's an infinite number. So instead of just looking at your local geography of potential good ball players, now you can look at the entire country and beyond all at the same time.
Yeah, that you think about that from a resource allocation standpoint. Like you said, you move it to the computer, and now you've got an unlimited amount of opportunities. I'm just thinking about, as a farmer, you talked about once it does get in the field, and we're doing some of these phenotypic screenings, different measurements, whether that's, with drone technology, with folks like yourself that are coming out and taking, readings on iPads and, notebooks and all that stuff. How does that phenotypic information that you all are taking notes on, how does that go back to help make the funnel better, more efficient when it comes to us ultimately driving the proper selections?
Yep, great question. So that phenotypic data is actually the base data of how we make the predictions. So to give you a little bit of background, in my research in Washington State, most of my research was actually focused on what we call genomic selection. So what genomic selection is we can leverage hybrids in the field. So we collect phenotypic data on them, yield, moisture, test weight, disease, you name it, right? We can run DNA markers on that, and we can kind of create a model that connects the two, connects how things perform phenotypically based off of their genetic markers, right? And because of that, we can go back into a pipeline on things that have only genetic information on it, right? Haven't been in the field, but we can run DNA markers on it. And through predictive modeling, we can actually predict the phenotypic performance from the genetic markers. And the reason we can do that is we take all that phenotypic information, like I said, and actually train a predictive model on that connection. So it's very, very important. And utilizing new tools like remote sensing and drones and all the new technology that we see in our R&D space of our phenotyping, all it does is build better and better phenotypic traits, new traits that maybe we've never been able to see before with our naked eye, right? That help us really characterize that hybrid plant, really characterize, every aspect, of that growth and overall performance, right? You might only originally had a couple handful of traits for even agronomics. Now we have, upwards of 9, 10, and then plus when you start getting into the realm of just general characterization of that canopy and things like that, right? So all that can be trained or can be used in a model and trained on to predict and improve our performance overall.
So Lance, help me understand. You're talking about this model, and you're talking about looking at this and essentially doing these crosses from a digital perspective almost before you would ever do it in the field. Help me understand what that looks like. You envision almost like a video game type thing where you're dragging one and crossing it with the other and things like that. But help us and our listeners understand exactly when you say you run these models and you look at these things to evaluate it, what does that actually look like? Put it into some frame of reference for us so that we can recognize maybe what you're actually doing that would make sense.
Yeah, good question. So unfortunately, it's not as cool as dragging and dropping. Essentially, I can, say a list of of inbreds A and another list of inbreds B, right? And we can make a complete set of crosses, which we call a diallel cross. It's every combination possible, or we can make subsets of that, or it can be directive crosses. But essentially, when I say make the cross, it's essentially taking A and B and simulating out the genetic marker recombinations between the two parents. So think of like, how your parents had you. I can simulate out what your siblings and yourself would look like, right, on a genetic basis. And then based off of that genetic marker profile that you have, I can take those markers and predict for each individual trait. And so essentially that's all done in the background. And what I have is essentially as simple as like an Excel file with crosses and rows and traits and columns, and it just going through as much data. And we have a ton of tools to help us, dig through it and improve that selections and trim that process. But at the end of the day, that's essentially what you're looking at. And the very basic of it is just a huge Excel file. And it's my job as a breeder and trained data scientist to go in there and make the best decisions possible.
Carl, maybe this is too simplified, but this is what I remember. I remember our genetic experiment from college when we were looking at fruit flies. Essentially what Lance is doing is he's doing that same thing, but in a much larger kind of scale. And he's looking at those separations. We were looking at colors and wing shape and all those kind of things. Yeah. He's essentially doing the same thing, but on a much grander scale because of the way that the genome of corn is compared to our little fruit flies.
Right. I'm just thinking about a corn breeder. If they were 40 years in the past and they were listening to the conversation we're having today, how they'd feel about just literally the unlimited number of combinations one can make, and with each successive generation that goes by, you produce even more inbred diversity, so you have greater and greater numbers. I would think at a certain point, Lance, if we didn't have these tools, the burden of being a corn breeder it'd be immense, because you'd have too many cats you're trying to herd, to come up with those optimal populations. So it sounds to me like this is a very data-driven process. Not getting too close to the secret sauce here in Pioneer, but if you were to just broad stroke talk about how within the industry you've heard of others leveraging these mass data sets, and this concept of machine learning and artificial intelligence, what potential do you think there is for a corn breeder with the amount of data that you all are using today? Just from an industry perspective.
Great question, right? And if you're going to dig deep into how I really do my job, just because, like you said, I have as much data as I could possibly want. Sometimes it's too much, and that's where we utilize these kind of tools to help us summarize and make selections, right? So as simple as like AI and things like that, you always, a lot of people's connections with that is, talking to a chatbot, right? Mm-hmm. Well, sure. That is, very directed directions and things like that. But, those are large language models that, they can go across different modalities of data. And what I mean by that, they can ingest essentially, things like audio, things like text, things like images, things like that.
Tabular data, right? Yeah,
exactly. Yeah, and it can create patterns and extractions from that, right? That's what it does when you create prompts, or you give it images to go through, or things like that. We do the same thing just with genetic data or phenotypic data, or drone data, things like that, right? And you can create models, and machine vision a lot of times is how you can, we've been using that for a long time. That's how all drones and all research works, is images, and you can extract different values and things like from individual pixels, whether it's color or other types of sensors like multispectral or LiDAR and things like that, right? That's the basis of all that. We can take those same models and apply them to data as well to help us make and improve selections. But now with AI, they can actually allow us to make suggestions beyond what we traditionally done. So, before you would make selections with these models and you have, simple recommendations on outputs of, what is better than others. But with AI, you can actually make creative selections, right? It can go beyond what you are physically seeing or what you are trying to validate on beyond going from a single trait, making selections to every trait and creating trait profiles and things like that. I recently I was at a conference for plant breeding, and there was a lot of posters now coming up with methodologies and how they're applying this technology. Again, we've been applying a lot of this machine learning data in remote sensing realm, especially as we characterize, you know, phenotypes and canopy and things like that, right? But now we're applying it to data and actually replicating selections and things like that. And it's a really interesting field because now with the power of AI, we're just going faster and faster and faster. I like to think of it as it's a newer discovery, especially in R&D, because these models do so well with large amounts of data. Because I no longer have to rely on like a computer engineer or other really smart people to help build technology and tools for me. I can leverage these models to do it for me. And because I'm working in a domain that I have a lot of knowledge under, I can ask the appropriate questions for it too, right? And so, similar for you guys, if you'd be able to work with AI, you would know all the agronomics that you'd really want. And, you're like, oh, what if I could do this with, these observations I've been having in fields and things like that, or these images I've been taking, or you name it, right? You have the questions and knowledge around that. So your use of AI would be exponential in the field of agronomic and just in field observations and different field technology, like things like that, right? So the more you can leverage and ask the correct questions and have it help you do your job, the better you're going to be. And because of that, it's our our pipeline and R&D has just been exploding. It's an exponential curve with this because it just makes us go that much faster.
Bryan, whenever you hear a breeder talk about exponential curves, right away, my mind as an agronomist, I'm thinking about genetic gain. I mean, we're going to be leaps and bounds, right? Is that ill-informed? Is that too simple? How do you reflect on some of this conversation?
Well, two things that strike me, and Lance, I've gotten to know over the last several years. And I've been fortunate to know a lot of corn breeders in my history with Pioneer. I am yet to meet a Pioneer corn breeder, a scientist who is technology averse. It just doesn't happen. Your question about what would the breeders of 40, 50, celebrating the 100th anniversary of Pioneer, if we go back and we were able to talk to Dr. Baker, what would he say about these technologies? And I have to believe that he and all the breeders I knew would be enthusiastic for them, because it would have made their job easier in one respect, but all of the information that they craved and wanted to know from a genetic standpoint, they would now have been able to dig into. If you think about Dr. Baker and many of those guys, they made selections much more from a phenotypic perspective than a genotypic perspective. I mean, they didn't have the genome to look at. They didn't have the markers that Lance talks about to use to try to sort these things out. And so that's the one thing that sticks out to me. The other piece of this, and I was with you on yield, but my question for Lance very directly is, as you sit here as a current breeder and you look at the next 20 years, maybe even shorter time frame than that because of the technology we're talking about, what's the one question or the one thing that perplexes you that you're most excited to be able to deploy these technologies on, Lance? I mean, what's the one burning corn breeding question or trait or whatever that you're after, or you've really got, kind of an itch to try to solve, that you think these tools might be the thing to get us over the hump, if you will?
Great question. The first thing that comes to mind, especially for me as corn breeder here in Indiana, is tar spot, right? So a lot of these tools, technologies have indirectly been really helping us Pioneer to really have the tolerance, have the industry advantage in tar spot, right? But it's a relatively new disease, in North America. And not only is it relatively new, it's different than where it's been before. So a little background on that, right? Tar spot has been in Central America, like Mexico and stuff, for a very long time. But in that geography, it's actually a combination of two different diseases, right? You have the actual fungal pathogen, the little tar spot stromata, that little dot, black dot, right? Then you have like kind of a frog eye type lesion around it, and that's a different fungal pathogen. And when those two are both present, that's when you generally see yield effects on that hybrid. But it's also because tar spot's been around a long time, and there is like true resistance and true tolerance in that germplasm. In North America, we only have or so far we've only really seen the stromata, that little black tar spot dot, right, that you can't like rub on. And because of that, we're still trying to truly understand how, like, why there's a difference there. And there's some really good articles on the Pioneer website. Like, if you want to dive deep, it gives really good information on the background and genetics of tar spot and the tar spot pathogen. So I highly recommend checking out those. We have some really good research agronomists that have put together those articles on the Pioneer website. But because of that, it's still relatively new in our germplasm. We haven't really faced this disease. And so utilizing this new technology, like AI and machine learning, things like that, my road to discovery is just so much faster, kind of like what I mentioned before, right? And so, already you're building AI models in the public space to help identify new traits and new QTLs, which is the genetic control of different traits like disease resistance. Maybe we look at one of our upcoming end of the decade releases for our commercial side. We have the multi-disease resistance loci, which is where we're genome editing multiple traits together in a single stack to put into hybrids at once, right? So we have 4 different diseases. And what that does is it makes it so I myself as a breeder do not have to put those traits in from the very beginning, and I can focus on improving these like yield, knowing that I will have the disease resistant traits integrated into my hybrids, right? And so it can actually allow me to select even more for yield and things I really like to select for. The same thing that those models help us do is, figure out those things to gene edit. Those traits are already known, so it's a very easy application of gene editing. But there are new traits that we're always exploring, always targeting. We are a industry leader in gene editing and gene editing technology, and that's really where the future of a lot of our plant breeding efforts really going to go. And these AI models really help us do that, right? We already are seeing publicly available models, AI models, LLM models, through universities that are predicting new disease resistance genes and things like that, utilizing relatives and things from different species to help us predict those. And so essentially what that can do, in this tar spot case, is potentially help us figure out gene edits and targets for that, even into the future. So that's one of the really exciting parts of the breeding, or the future of plant breeding, is to see kind of where that goes, especially as regulatory framework around the world is really improving and being very very hopefully there's a lot of opportunity even in areas of the world that we haven't had biotechnology in the past.
Lance, I think of all that opportunity, and it makes somebody reflect. I'm sure maybe farmers are having this thought process. Does this make plant breeding available to more people? Do you think you're going to have more players that get into this space as it gets easier, if you will, or is it going to make those great plant breeders even better? If you think about the overall enhancement that access to these types of tools gives us, you still have to have the data and the know-how to be able to get it to work. But how do you reflect on that? If somebody wanted to start things up and compete against a pioneer, if you will, or if you're sitting there in your office there at a land grant institution, how do you think this levels the playing field or differentiates as you reflect on this opportunity that we're staring down?
That's a really good question. I mentor students and and others through my organization, and things like that, and for plant breeding. And I hope everyone can get into plant breeding. It's one of my true passions. It's a lot of fun, and why I love every single day going to the station and doing what I do, right? And so if it allows more people to get into it, great, right? One thing that when I mentioned these tools though, is having the proper knowledge and training to utilize these tools is key, because it allows you to truly understand what you're doing and direct those tools appropriately, right? The vast majority of plant breeders in our industry are PhD trained plant breeding, right? And PhD is a philosophy, as a doctorate of philosophy, right? So really it's learning how to think and how to learn and applying that to whatever domain you're in, right? And so you can think about it the same way. It's doing is teaching you how to ask questions. And that's where these tools excel, is when people know the questions to ask and how to ask it. And of course, resources to ask those questions.
Sure.
That's where you get a huge advantage.
Carl, I think the other thing I'd be remiss about this is I think just trying to start your breeding program from scratch would be incredibly difficult. We've got 100 years of pedigree information, which makes us a little bit unique. That's not something Lance has talked about, but the fact that we can go back and actually do that and connect a modern day hybrid to, one of the first crosses that, Henry Wallace did, it makes us a little bit unique. And not everybody's got kind of the bench, to go back to your sports analogy, sitting there to be able to, kind of put these tools into motion with. And so I think about some of those extension programs, to be real blunt about it, they don't have the firepower that we do in terms of just the pure genetic stock to start from. And so I don't want to give somebody listening the idea that they could start their own breeding station, in the back of the shop there. They might be able to, but I think it would be a pretty monumental undertaking to get done, to be fair about it.
Yeah, it would be a challenge. I mean, you can do it how breeders
Sure.
have done it for 100 years, and just pedigree selection and things like that. The difficult part is the newer technology, right? That's something that we invest very, very heavily in, and why I have so many resources as a breeder to do my job. And that costs a lot of money, right? It's everything from ground to put a research plot on, to the genetic markers, the predictive power of computers and modeling, right? That all, that's a lot of resources that we invest in and try and build out the most robust and industry leading breeding pipeline possible. So.
No, it's a competitive space as it is. Better tools doesn't mean that you'll get more players, but the players that you have are going to be playing that much harder, I think, is maybe the way that I reflect on that opportunity. And nobody likes to hear the idea of seed prices going up, but as you continue to race towards more and more genetic gain, that comes at a cost, right? And to be able to be at the top of the heap, it is a considerable investment. And I think that innovation is something that we're very proud to bring from the Pioneer brand. Ultimately, it comes down to how much better can we be each and every day, and Lance and team are a huge part of what differentiates us. I mean, the crown jewels of Pioneer are the it's the germplasm, and it's the ability of our breeders to bring the most value with every cross they make. And I think it's super compelling when you hear Lance talk about, there's a lot of breeding I can do on the computer that never has to reach the field. I can pick more winners because I start with them, as opposed to starting with winners and losers and having to find out. And I think that's just such a compelling piece to what him and the team bring. And ultimately, it's up to Bryan and I to figure out exactly where they fit. And we've got a lot of resources behind us to make sure that those in the field are successful from our products as well. So, Lance, I'll leave the last word with you. Anything that you want to impress upon folks, I'd encourage them, if this has struck a chord, check out the Breeding Bites podcast that you host. It'll give you an even deeper dive if you want to think about how a breeder, not a corn breeder, but how a breeder wakes up every day trying to advance the field. But with that, what would you leave folks with?
It's going to get exciting, right? It's a new era with all these new technology and tools, and it's going to be very exciting to see where we go from here.
Bryan, anything that we missed? Anything that you wanted to sneak in on Lance before we let him go? I know that there's got to be a dozen questions that are coursing through you right now that you know better than to ask. That'll have to wait until these microphones are turned off.
Yeah, nope. It's always a really great thing for me to sit down with Lance and some of his counterparts. I learned something that I can take right to the field every time, and our conversation today was no different. And so I'll be excited to talk to my customers and my sales reps about some of the stuff that Lance has shared with us today for sure.
Awesome. Well, if you are listening and you do want to ask that confidential question to Lance, go ahead, filter that through Bryan and I. We'd be more than happy to at least receive the question, see if we can get an answer. But with that, thanks again for listening to the Outstanding in Your Field podcast, and we will see you down the road.
This has been another episode of Outstanding in Your Field. Like and follow our podcast wherever you are listening. We've got a new episode at least once a month. You can also find us on YouTube by following Pioneer Seeds. You can find me on Instagram at B_K_Schrader.
And I'm Carl Joern. You can follow along with me at Joern on X or on Facebook at Joern Agronomy. That's CJOERN.
That concludes this Pioneer Agronomy video podcast. Visit our page on pioneer.com and follow us on Twitter and Facebook for more agronomy insights.